Hello, here's your Chapter 1 test. I know you're excited to get going. So here we go. On the first 3 questions, all we're going to do is plug and chug. You're going to substitute the number in for the letter, as I've drawn these arrows already ahead of time for you, and work it out. You may use your calculator. Down here on number 4, we're asking you to find the volume of the cube. A cube is a 3-dimensional square. So each side is 4 by 4 by 4. Okay, and the formula for volume is either you could use take the side to the 3rd power, or you could take length times the width times the height. Either one, you should get the same answer. As you can see, we're skipping number 5. That's why I put a big red X through it. Moving on, 6 through 8, this is order of operations. This is PEMDAS. Okay, so I'm just going to jot that over here to the side. Parentheses, exponents, multiplication and division, addition or subtraction. Remember, these two and these two, you just work whoever comes from left to right first. Okay? If you have a question, make sure you ask. And 9 and 10, you just got to write the algebraic expression. So the sum of a number x and 9. Keyword there is sum. Number 10, 6 less than a number x. Turnaround word right there, less than. Okay, so flip those around and write your answer. Okay, 11 and 12, we're just continuing exactly what we did on 9 and 10. 3 more than twice a number x is equal to 13. So 3 more than twice a number x. Remember, how do we twice a number? And 3 more than that is equal. So we're going to have an equal sign here to 13. Number 12, the product of 5 and a number x. So product, keyword or hot word, is less than 60. Is less than. So now we're going to use one of them gator mouths. Okay, you can see 13 through 20 we are skipping. Down to 21 and 22. Tell whether it's a function or not, and then identify the domain and the range. Okay, so just look for each input. We can have only one output. Okay? So as long as none of these numbers are the same, you're going to be a function. Same way over here, only the difference is, zoom in a little bit, you need to make sure, remember, 1 box of brownies cannot make 2 pans of brownies. Okay? So if one input can only have 1 output. So if there's 2 arrows coming from anybody, it's not a function. But now on both of these, we need to state the domain and the range. Okay, remember, D comes before R, just like I comes before O. So just write domain and list them off to the side. R for range. And list your numbers off to the side. On number 23, similar concept. Just make sure none of the inputs can be repeated. Okay, as long as they're not repeated, you'll be a function. But they want you to write the rule. So let's rewrite this actually. I'm going to write this as x and y's. So 3, 6, 8, 10, and 13. -4, -1, 1, 3, and 6. So first look at the pattern here. If it's not a consistent pattern, then we look at the pattern going down, which I believe appears to be the way we want to go. It looks like we're just adding 3 every time. Then again, maybe we're not. So actually, I was wrong. It looks like we're subtracting 7 on each of these. So if we're subtracting 7, now you write the rule for the function. Over on number 24, we're going to zoom in tight here, and we're going to write the coordinates out. We're going to just write x and y. So we have 1, 3. We have 2, 4. 3 and 5. 4 and 6. 5 and 7. So now take a look. We're gonna have a consistent pattern here. Figure out the pattern, and then you're just gonna write the rule. So it'd be, you just write f of x equals what? Whatever the rule is. On number 25, all you need to do is let's fill in our domain, which is our x values. So 0, 1, 2, 3, and 4. And then plug in each one of these in for x and work this whole part out. That will be your output. You get here, then you need to graph them, okay? And then down here you need to write the range. This is going to be your range. So whatever you get when you work out this side, this is your range, your y's down below. Number 26 says describe the difference between an expression and an equation. Okay? Expressions are going to look like this. An equation is going to look like this. So you write a sentence explaining the difference between those two. Number 27. A bicycle travels at an average speed of 15 miles per hour. How many miles does the bicycle travel in 1.5 hours? Use the formula distance equals rate times time. So 15 miles an hour, that'd be a rate. 1.5 hours, that would be your time. You need to find your distance. Okay? So plug those into the formula. Make sure you label your answer. If it's a distance, which would we use? Would we use miles or would we use hours to measure our distance? Then down below you have a couple bonus problems here. I'm not going to go any further than that. Let you read them and work on them yourself. If you have questions on any other part of the test, let me know. Feel free to go back and listen to any part of it again. Hope it helped you out, and have a great day.